So we're going to work with slope-intercept form and from standard form or other forms of an equation. Let's start with problem number one. Number one is already graphed for us, but we want to write the equation of the line in slope-intercept form. So first, let's recall what slope-intercept form is. Slope-intercept form is y equals mx plus b, where m is the slope, which is rise over run. This talks about the steepness of a line. The b is the y-intercept. The y-intercept is where the line crosses the y-axis, and this is where we want to start. So I'm going to write my framework of y equals mx plus b, but I'm going to leave a space for my m, my slope, and a spot for the b, the y-intercept. So I need to fill in these two sections with the slope and the y-intercept. Let's start with the y-intercept. The y-intercept is where the line crosses the y-axis. The y-axis is the up and down, the vertical line. And the line crosses the y-axis right here at -3. So that's my y-intercept. My slope is then finding the rise over run from 2 points. I usually start with my y-intercept and create a right triangle going left to right to another point on the graph. So I'm going to go up and over to the next point that I see. The rise is going up 2. Up means I'm going positive, and then I'm going right 3. Going right is also a positive as I move towards the positive numbers. So my slope is +2 over +3, or 2/3. And that is my final equation of the line. Y equals 2/3 x plus -3. Moving over to number 2, we're given the equation in standard form, and we want to rewrite this in slope-intercept form to graph it. So the first thing I'm going to do is rewrite my equation so I have room to solve for y. In order to solve for y, we're going to start by removing the x term. Then we are going to divide by the coefficient of the y. So let's start with the x term. 10x is a positive because there's no sign in front, so I know it's a positive 10x. The inverse operation is negative, or subtraction. So we're going to subtract 10x to both sides of our equal sign. On the left side, the 10x's cancel, leaving us with -3y. Slide down your equal sign. And I want to be in the habit of writing my x term first so that we're following the order of slope-intercept form, y equals mx plus b. -10x and -15 are not like terms, so I'm going to write what I see. I have a -10x and I have a -15. Now I want to divide by the coefficient of the y, which is -3. When I divide by -3, I'm dividing every term by -3. The -3y divided by -3 cancels down to 1y, or y. -10x divided by -3. I want to start with the numbers, -10 and -3. Negative divided by negative is a positive, and 10/3 cannot be simplified, so we're going to leave it as 10/3. Bring down the x. Now I have -15 over -3, which is a +5. From here, I can classify my slope and my y-intercept. The slope is 10/3. And the y-intercept is 5. So we're going to start by plotting 5 on the y-axis. Now my slope is 10/3, which means technically I would go up 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and over 3. However, I don't have any coordinate plane there. When this situation occurs, we can always go the opposite direction. So +10/3 would mean up and right. But what if I keep this as a negative 10 over a negative 3? I know double negatives cancel out to a positive. So the negative 10 would mean I'm going to travel down 10, and negative 3 means I'm going to the left 3. So from my y-intercept, I'm going to count down 10 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then left 3. 1, 2, 3. And that's where I can make my next point. Now that I have 2 points, I can connect them with a straight line. Let's take a look at problem number 3. Number 3 is almost in standard form, not by definition, but we don't have the y by itself, so it's not in slope-intercept form. And I want to get this into slope-intercept form. Slope-intercept form means the y is by itself, which means I need to remove the negative 1/2 x from the left side. If you would like, pause the video and try to do this on your own, and when you're ready, you can replay to check your work with mine. All right, so negative 1/2 x, since it's a negative, the inverse is a positive or addition. So I'm going to add 1/2 x to both sides of the equation. When I do that, on the left side, the negative half x's go to 0, and I'm left with y. On the right side, I have 4 plus 1/2 x. Those are not like terms, so I can't combine them. I am going to write what I see, and I'm going to rewrite it so that the x term comes first, and then the constant. Now I have slope-intercept form. What is the slope of this line? That's right, it's 1/2. What is the y-intercept of this line? That's right, it's 4. So now we're going to graph our equation by starting with plotting positive 4 on the y-axis. The slope positive 1/2 means I'm going to count up 1, right 2, make a point. I could keep this pattern going, up 1, right 2. I could also go back to my y-intercept and go down 1, left 2 to show that the line continues in the other direction as well. You need at least 2 points to make a line. So now that I have enough points, I'm going to connect them with a straight line. Arrows on the end to show that it extends forever in both directions. Finally, problem number 4, x equals 3. So this one looks completely different than our other 3 equations. One acronym that we can use to help us remember how to work with x equals a number or y equals a number is HOIVUX. It sounds silly, but it does come in handy to help you remember. The H stands for a horizontal line. Horizontal lines have a slope of 0. And the equation of a horizontal line is y equals a number. V stands for a vertical line with a slope that's undefined. And the equation is x equals a number. So let's take a look back at number 4. Number 4 says x equals 3. That means I'm going to be using the VUX in HOIVUX to help me graph. X equals 3 means that x is always equal to 3. No matter what y is, y could be 5, x is 3. Y could be negative 2, x is 3. X is always 3, so we get a vertical line going through x equals 3. Put arrows on the end to show that it extends forever in both directions.